In this video, we're going to look at how to graph a quadratic function if we're given the equation in standard form. And by standard form, I just mean y equals ax squared plus bx plus c. So if we're given the equation in that form and we don't have a TI-84 or any other graphing calculator, how do we graph this function? What's the easiest way to graph the function? Well, first of all, we have to know the shape. So that's step one here. We have to know the shape. So the shape of a quadratic is always a parabola, and a parabola looks like this. If the a value is positive, or like this, upside down, if the a value is negative. So once you have that down, then half the battle is won. Not really, but kind of. All right, so that's the shape. What else do we need to know? Well, all right, so let's just stick a little sketch over here so I can point to and refer to. All right, so that's the shape right there. Let's look at this point. What is that point called? Well, that point is called the y-intercept. It's where the graph hits the y-axis. So in order to see the y-intercept, in order to know what the y-intercept is, we need the value of c. So let's look at an example. We have an example here. Y equals x squared minus 4x plus 3. All right, we already know it's a positive a value, so we know that it's going to be this shape. And now we can figure out the y-intercept. And how do we figure out the y-intercept? Well, that c value tells us what the y-intercept is. So c tells us the y-intercept. How does it do that? Well, hold on. So, if you recall, well, if you take a look actually, on our graph, on the y-axis, x will be 0. So if we plug x as 0 in here and 0 in here, we get that the y value should be 3 on the y-axis. So our y-intercept in this case, because we have 3 as our c value, is going to be equal to, in this example, 0, 3. So one thing to remember is that the x value is always going to be 0 on the y-axis. The x value is always 0 on the y-axis. And then the c value will tell you what the y coordinate is. All right, so there is the y-intercept. The next thing that we should do is find the x-intercepts. Now, let's see. In this case, so sometimes there are 2 x-intercepts, sometimes there's 1, and sometimes there's none at all. In this particular case, we have an x-intercept here and an x-intercept here. It's where it crosses the x-axis. Now, just like how x is 0 on the y-axis, y is 0 on the x-axis. So what we can do is take our equation here and set y to 0. So what we'll have then is that 0 is equal to x squared minus 4x plus 3. All right, so we did that because on the x-axis, y will always be equal to 0. Now we can solve for x. And hopefully you are a pro at solving for x in a situation like this. We need to factor and then solve. So let's go ahead and do that. All right, to factor this, we need 2 numbers that multiply to get 3 and add to get negative 4. Or 2 numbers in this case would be negative 3 and negative 1. And that is equal to 0. So solving it, we get that x is equal to 3 or x is equal to 1. Which means in this case, one of our intercepts would be at 3, the bigger one, clearly, and the other one would be at 1. So I cheated a little. I knew what this graph would look like, and I did a little sketch that looked like the graph, but in this case, in your case, you would be finding out this information and then drawing the graph. All right, so while we're here, we might as well put the y-intercept here, and that should be 3. All right, so we found the shape, the x-intercept, and the y-intercept. What else is usually asked for? Well, the axis of symmetry is usually asked for, and so is the vertex. So I'm going to turn the page. I'm going to put the key information on the following page, and we'll continue with this question. Okay, so this is where we are so far. We figured out that the shape is a parabola that faces in this way because our a value is positive. We figured out that our y-intercept is 0, 3 because our c value is 3. And we made this equation equal to 0 because on the x-axis y is actually 0. We factored and we solved and we got 1 and 3. So while y is 0, x is 1, and when y is 0, x is also 3. So that's where we are so far. Now it's time to find the axis of symmetry. And what is the axis of symmetry, you ask? Well, it's a line that goes straight down the center of our parabola. It splits it directly in half, so it's a vertical line. Hopefully you recall from studying lines that a vertical line has to have an equation, x equals something. We don't know yet, or maybe we do, but we do know for sure it's x equals because it's that vertical line. Everywhere on that line, x will be equal to something. All right, so how do we figure out what that is? There are two different ways, and I actually want to show you both. There's one way called the axis of symmetry formula, and that states that, so let's write this down. Axis of symmetry formula states that x is equal to negative b over 2a. So in this particular case, a is 1, b is negative 4, and c is 3, which we don't need, but good to know anyway. So x is equal to negative 4, so that's coming from our b here, over 2 times a, and a is just 1, so 2 times 1. All right, so x is equal to negative 4, negative 4, which is just 4, over 2, so x is equal to 2. That's one way to do it, using the axis of symmetry formula. I actually prefer another way of doing it, so I'm going to put a little line here so we know that this is two ways of doing the same thing. All right, we already found the x-intercepts. There's one x-intercept here, and there's one x-intercept here. There's one, let's write it down, at 1, and there's one at 3. And if you just find the average of those two numbers, 1 and 3, you will get the axis of symmetry. So the axis of symmetry is the average of the x-intercepts. Really good to know. So you can also find the axis of symmetry by averaging the x-intercepts. So here we have, that's supposed to be an S. All right, so there we have x equals 1 plus 3. So we're averaging 1 and 3. That's two numbers, so we divide by 2. And we get x equals 4 over 2, which gives us 2. Same answer. We're just doing it in a different way. So whichever way you prefer, it's good to be familiar with both. All right, so now we're almost there. Now all we need is the exact point at which this hits. So we already know the x-coordinate of that point because we just found the axis of symmetry. So we know that that x-coordinate has to be 2 because x is 2 everywhere on this line. So that's a good start. So what else do we need to know? Well, we need to know the y-coordinate. But first, let's make note of the fact that the x-coordinate is the same as the axis of symmetry. All right. so once we know that, we can put 2 comma and then it's 2 comma something. We'll leave that blank for now. But we started off with this equation right here. It's a relationship between x and y. So we're going to use that relationship between x and y and figure out what y is when x is 2. Alright, so our relationship is that y is equal to x squared minus 4x plus 3. So y is equal to 2 squared minus 4 times 2 plus 3. And when you work that out, you should get that y is equal to -1. So now we have our vertex. It's 2, -1. And we're done.